Hello everyone, I'm Karthi Vignesh. This video we're going to talk about exercise number 810 operating system that which is contiguous memory allocation. So in this experiment we are supposed to implement three different memory allocation techniques known as the worst fit, the best fit and the first fit. So in these three techniques we'll be allocating processes to memory resources based on certain conditions. So we'll be going through those conditions and we'll be going through the program that I've written for all the three questions here. So I'm gonna these are three questions that I created. So first I'm going to the first one. The first one here is the best fit algorithm. So the best fit algorithm, the computer will just check out the processor sizes and the block sizes, the memory block sizes, and then it will allocate the best possible partition, memory partition to the respective process resource. So basically, let's say a process has let's say a process is of size 400 and we have two blocks, namely 450 and 500 size as sizes. So in this basic algorithm, the computer will go through the algorithm will make sure that the process is allocated to the least possible size and also make sure that it has enough size available that has been required. So in this case, 400 is the process size, and we have the memory block sizes 450 and 500. So the process will be allocated to the memory block with the size as 450. That's the best fit. So in this one, first I'm declaring the variables required for the program, and then I'm printing this is the best fit algorithm, and then I'm getting the number of blocks, and we are getting the size of each block. Then I'm getting the number of this is the scanning segment. We're getting input from the users, and then I'm printing the number of process. Then I'm getting the value for each size of each process. After that, I'm going to the main code. In this main code, this is the main code. In this one, we are just exactly doing what I just verbally told you, which is checking the least possible memory partition which can afford the minimum requirement by the process. So after that, we are just printing the output to the user. So I'm gonna execute the program now. C, and I'm gonna see the output. So this is the output that I will be giving through all the three algorithms, and these are the respective results that are expected from them. These results are from the internet, so these results should be correct as long as my program is correct. So the first one is we have 5 blocks. I have 5 blocks, and the block size is 100, 500, 200, 300, and 600. And we have 4 processes: 212, 417, 113, and 426. And the blocks, these are the blocks allocated to the process 1, 2, 3, 4 respectively. So the first one is allocated to 4, second one is 2, third one is 3, and fourth one is 5th. And as you can see, the output matches to the sample output that has been given in this one. So the program works as intended. Moving on to the next one. The next one is the first fit algorithm. The first fit algorithm, in this one, the computer checks whether the memory block that we are going through fits the process requirement. It doesn't matter whether it's too large, as long as it has enough space to accommodate it. The algorithm will just assign it to it. For example, let's say the first memory block is 700 size, our second memory block is 500 size, and your process is 450 size. So when the algorithm is being executed, it just assigns the memory block 1 to the process because it has enough memory to allocate it, but it doesn't go through the second block, which is the size of 500, which is also the best fit for it. So that's how this one works. And in this one, again I'm printing the algorithm name, and I'm getting input for the blocks, size of each block, block numbers, sorry, this is the scanner statement, and number of process, and the size of each process. After that, this is the main set of code. In this one, this is the main set of code. In this one, again, what I'm doing is it just checks whether the current block has enough size to accommodate the current process that we are going through. it just goes from top to bottom and assigns as soon as the requirement is satisfied. It doesn't matter whether it's a bad one or it's the correct one. It just assigns as long as the requirement is satisfied. So, and after that we are printing the output to the user. So I'm gonna execute the program now. Again, 5 blocks, 100, 500, 200, 300, 600, 4 process, 212, 417, 42, 46. As you can see, these are the outputs. As you can see, this is the output for it, and the process number 1 is allocated to the block number 2, which is this one, and the process number 2 is allocated to the block number 5, which is second one. After that, the process number 3 is allocated to the process number block number 3, which is also here, and the process number 4 is unallocated. That's why the process numbers both of these are unallocated. So moving on to the next one. The next one is the worst fit algorithm. In this algorithm, basically we are just gonna assign the worst possible memory for any type of process. For example, we'll be assigning the process size of 100 to a memory block of 900 or something like that. This is basically the least preferred algorithm because it gives the worst possible result. That's why it's called worst fit algorithm. So in this one, I have written instead of making the whole program inside the main program, I've created a different, I created a separate function called worst fit, and I'm calling it from the main function. So inside the main function, I'm just printing that this is the worst fit algorithm, and I'm getting inputs from the user. After that, I'm pausing it to the worst fit algorithm, worst fit function. Inside the function, what we are doing is we are creating a allocation array, and it's full of -1s. I'm filling it with -1. We'll talk about it later. After that, inside this one, I'm just checking whether the block size is the worst possible size for the current process. As long as it's the worst possible size, it is being allocated. And after that, while printing, I'm checking whether the allocation array's value is -1. Why I'm checking here is, as long as we are declaring everything as -1 here. As long as the process has assigned a worst possible block, the value of allocation array will not be -1. So when it is not -1, when it is -1, it means that that specific process has not been assigned to any blocks. So we're just using that condition here to print whether the block has been allocated or not. So I'm gonna execute the program now. Again, same input, 100, 500, 100, 100, 600, number of rows are 4, 212, 217, 112, and 15. As you can see, this is the worst possible case, and it matches the output that I have here as a sample output. So all the three programs here work as intended. So those are the three algorithms that are required to be executed in this specific exercise number 8. So yeah, that's it for today's video. See you guys in the next one.